Hello, welcome to the first video recorded lecture of Comp 3490 Computer Graphics 1. Alright, so last class we just did a quick introduction. So you didn't miss anything. There's nothing to really remember. Just an intro to the course. And an intro to computer graphics. That's all we did. So today we're really going to get started with the nitty-gritty, starting to learn the first pieces, starting to learn the building blocks of computer graphics. That's today. All right. So I'm going to start by talking about rendering. Rendering is a fundamental problem in computer graphics, and you might have heard about people talking about rendering before. It's not a big deal to understand it. It's simply the problem of going from data to display. It's from data to display. That's all that rendering is. So you can imagine now that in your program in memory, you have maybe a linked list of some kind of data structure, maybe a tree, whatever. You have a game map that you've stored, you've loaded in some images, right? You have some points that you want to render. So you have all this data, but it's pretty abstract. The rendering is simply the problem of going from that abstract data to something on your display screen. That's it. And most of this course will be dealing with rendering in one form or another. Right, so you have all this abstract data, and maybe when you render on your screen you get a nice happy face. Yay, right? Okay, I'm going to highlight these. By the way, I'm really bad with being consistent with my highlighting, so the colors don't really mean much except for pay attention to them. So the first thing I want to talk about when it comes to rendering are pixels. Again, you've probably heard about pixels before, but I want to talk about them a little bit more than you might have thought about them before. What are pixels? Pixels are simply the smallest, come on, there we go. Pixels are the smallest individually accessible display elements. So this accessible is the key here. You can read and write them, right? You can put them, you can read them, and see what they look like. Give them a color and also see what's already on the screen. Predominantly, these are squares, but I will talk a little bit about some alternatives. So pixels are generally squares, predominantly. Squares. And there's no real reason for this except for the fact that it's for simplicity. Maybe I'll jump over to my slide real quick just to show what I mean by this. So here's my, does that work? I hope that works. I don't think that works the way I think it works. Let me just change, no presenter view. I think that's right. Aha, this is what I wanted. All right, so here's an example. I have a screen. This is an old computer screen, Commodore 64, something from the 80s. And you see this blocky font was very common. But if you zoom in, you see we have these square pixels. In this case, they're on or off. Off is black, on is blue, or it could be white or green. And you take a letter like the A or the R, you look inside, and it's made up of these little square blocks called pixels, kind of like a Minecraft world. So that's all that pixels really are. Okay, I can go back to my iPad. So they're predominantly squares. There are alternatives, and I'll talk about that, but you won't really deal with these in this course, but it's important to know that alternatives exist. The most common alternative these days we call anamorphic. So we have anamorphic pixels. Now this sounds really exciting. Anamorphic, they're going to come a lot. No, nope. All that anamorphic pixels mean are non-square, rectangular, like this. And we do this because on certain displays, one dimension is more important than the other. Typically on a TV, you have a lot of pixels this way and a few this way. So you'll have video compression systems that'll actually have anamorphic pixels, and they'll compress one direction more than the other, and your pixels become rectangular instead of square. You'll come across this if you do video encoding stuff. If you work with old CRT displays, you'll hear about anamorphic pixels. All that it means is they're not square, they're rectangular, and you have to do some math to convert them. You might have seen this if you've done a video conversion and it went wrong and the image looked squished or squished. You just had the wrong pixel setting. But we won't really deal with anamorphic pixels in this course. These are typically for DVD, Blu-ray, that world, or TV. Yeah, you can read up on this if you're interested, but don't spend too much time on it. There's also another format, and this is really dated now. We don't see much of this anymore, but you will see this in special use cases. And those are non-rectangular pixels. Non-rectangular. So if they're not square and they're not rectangular, what's left? Now let's see if I can draw this. One format that was pioneered in the early days were Hex Pixels. And if any of you have ever played tile-based board games, oh, I'm going to screw this up. There we go. You might be thinking, oh, that's kind of neat. Why on earth would people do Hex Pixels? There are actually a lot of benefits to these kinds of Hex Pixels. One is aliasing. We'll come back to this later. But when you have square pixels that line up perfectly like this, you end up getting a lot of jagged edges. If a line's coming through like that, you'll get this pixel black, and then maybe white and white, and you get a jagged edge. With these Hex Pixels, you're more likely to get a softer edge. The other cool thing about Hex Pixels is you get some free rotations. With our square pixels, I can rotate my image 90 degrees, 180, or 90 in the other direction, just by rearranging what way I draw it. I don't have to resample or recalculate anything. So I get 3 free transformations with a square pixel. With the Hex Pixel, I get 5. So in some systems where you wanted to do rotations without losing any data, especially in the old days, Hex Pixels were your go-to because you got these free transformations. Don't worry too much about it. The reason I'm explaining these to you is that so you're familiar with the idea and you might come across it. I've seen this hex pop up in some printing contexts, in some 3D printing contexts, and in old hardware, specialized hardware like wearables, but you won't do that in this course, okay? We're gonna stick to our friendly neighborhood square pixels, okay? But I wanted to talk about those. All right, so these are pixels. If we're dealing with pixels, we're dealing with something called raster graphics. Raster graphics is a really cool sounding word that's actually really boring. A raster graphic is nothing more than a graphic that's made up of a grid of pixels. That's it. So raster. Hey, look, I'm drawing your very first raster. Yay. Okay. So raster graphics are just these grids. If I have square pixels, my raster is square, but I could have raster with hex shape or anamorphic or whatever as well. So a raster graphics is just this. You have this grid of pixels, and each pixel has a color. I have a green, green, green. You can imagine I could make a yellow pixel here. I could do whatever color I want, and you can make shapes by, it's kind of like coloring it on graph paper, right? You can make shapes just by coloring the pixels on your raster. Raster graphics are perhaps right now one of the most popular forms of graphics in the world. If you've ever used a JPEG file, a PNG file, I forget what JPEG stands for. Joint picture something group. PNG is portable network graphics. I won't get into the details of different formats. That's more of an image processing course. But feel free to ask me if you're curious. TIFF you might have come across. Old days you would have seen bitmaps, BMPs. There's old PCXs, blah 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 blah. All of these are variations on the raster graphics format. JPEG uses Fourier type compression. BMP is no compression. PNG is lossless compression, doesn't lose any detail. This TIFF is made more for cameras and more for printing. They have all their features, but at the bottom, all that these formats do is give you a grid of pixels. Okay, so I'm going to go back to my slides for a second. Yeah, so here we go. Right, this is a raster graphics. Bam, it's a grid. You put pixels in. I'm also going to show this one, and I'll come back to this again a little later. This is a raster graphic. I have this nice smooth looking leaf. If you zoom in, it's just a grid. In fact, I recommend you try doing that with your favorite paint tool. You zoom in, you zoom in, you zoom in, and you should see these square blocks. Now these days, some of the programs try to be clever and they don't show you the square blocks anymore. They try to make them fuzzy, make them look really nice. Well, that might look nice, but it doesn't help us trying to understand how raster graphics work. Okay, let's go back. Hold on. Maybe now's a good time to stop and take a break. So I'll stop this video here, and I'm going to continue with this topic when we come back.